Okay, so looking at math calculations for tank duration, both in a gas and a liquid. Um, this is, again, looking at the different sizes. You guys are going to know the H tank, the E tank, and the D tank, okay? So when you're talking about gas, specifically, really separate in your mind because we're going to do a different math calculation for the liquid oxygen. So this is just talking about oxygen as a gas. Volume of gas is directly proportional to pressure, okay? So we talked about how a full tank is 2200 psi, all right? But obviously, if you look at like the previous slide, we have different size tanks. So we have these conversion factors to help us to compensate for the fact that tanks are different sizes. So if a full tank of gas is always 2200 psi, you then will use this conversion for an H tank, you'll use this conversion factor for an E tank, and this conversion factor for a D tank. So you take the pressure that you're given for the tank times the cylinder factor, and that's going to equal your volume of gas in liters. Okay, and this is kind of one of those things where if you do a couple practice problems, it gets a little easier to see what I'm saying. So, for example, how many liters of gas are in a full E tank? So it's full, so you know that's 2200 psi. So you take that 2200 psi and you multiply it by the 0.28, which is the conversion factor for an E tank, and that's going to give you 616 liters of gas in a full E tank. Comparably, if you look at how many liters of gas are in a full H tank, again, full, so you know it's 2200 psi. You take the 2200 times the 3.14, which is a number that I'm just getting because that's the conversion factor for an H tank. You get 6,908 liters of gas in a full H tank. And you can see the size difference here in the sense that that E tank only has 616 versus an H tank has 6,908. So much, much bigger. The conversion factor is what's going to give you that difference in tank size, okay? So after you figure out how many liters of gas you have, you can now use that to figure out how long your tank is going to last for a particular scenario. And the one that comes up the most often is a patient that is on a tank that is running at a particular liter flow and they need to drive home or whatever else. So then we are responsible for figuring out how long their tank is going to last. And I would say I do this at least 3 times a week, probably. Okay. So again, kind of circling back, figure out how many liters are in a full H tank. So we did this on the previous slide. We took that 2200 full tank times the 3.14, which gave us the 6,908 liters. The next thing we have to do is figure out what liter flow of gas is being delivered to your patient, right? So let's say, for example, in this scenario, it's 4 liters per minute. So you then take your 6,900 liters, which is how much gas you have in your H tank, and you divide it by the 4 liters per minute that is getting delivered to your patient. This gives you 1,727 minutes. Okay, so that takes you to this portion of the problem. So this is just writing it in a different way. Tank duration in minutes is the pressure of the tank times the cylinder factor divided by the flow in liters per minute, okay? And that's going to tell you how long in minutes it will last. So this next practice problem that we're going to do is going to take it a step further because although this is taking us to minutes, we probably want it in an easier to decipher language like hours and minutes because not many people know how much 1,027 minutes is. So this is going to take the same steps we just did, and we're just going to take it a little bit further. So John is on a 3 liters per minute via nasal cannula and needs to go to the clinic for a PFT. A full E cylinder, so 2200 psi, is available. How long will the tank last in minutes and in hours and minutes? Okay, so going through the steps on this one. It's a full tank, so it's 2200 psi. times the 0.28, which is the conversion factor for the E tank, is that 616 liters of gas, okay? For step 2, you take your 616 liters, which you got from here, and you divide it by the 3 liters per minute that you know John needs, okay? So that's what's getting delivered to your patient. That brings us to 205 minutes. So you're gonna want to, awesome, another typo, convert the minutes to hours and minutes. So you take 205 minutes, divide it by 60 minutes. That's going to be 3.42 hours. A common mistake I see is that people stop at this point, and on their exam they write 3 hours and 42 minutes. But that is not the way that that works. It's 3.42 hours, okay? So you have to then take 0.42 times 60, right? Because this is a 0.42% or whatever of an hour. So you multiply by 60, and that gives you 25 minutes. So the tank duration for this patient is going to be 3 hours and 25 minutes. The next one that we're going to do is a patient is going from ICU to CT scan. There is an H tank and CT scan. The patient is on an oxygen mask at 10 liters per minute. How long will an H tank that is half full last? So big takeaways, you know that you have an H tank, so your conversion factor is going to be 3.14, which you guys probably don't have memorized at this point, but you will eventually. So you have your H tank, 3.14. The patient is on 10 liters per minute, so that's the other piece of information that you need. The other piece of information is the pressure. How long will an H tank that is half full last? So step 1, 1100 PSI. The reason we're using 1100 is we know that a full tank HED are always 2200 PSI. So half of that is 1100. So that's going to be our starting pressure. 1100 PSI times the 3.14, which is just the conversion factor for an H tank, gives us 3,454 liters. We're going to take that liter total that we figured out, and we're going to divide it by 10. And the reason we're going to divide it by 10 is that we know that this patient is requiring 10 liters per minute. That gives us 345.4 minutes. Where did it go? Okay. And then after that, we're going to convert it to hours and minutes. So again, you take your minutes and you divide them by 60. That's going to be your 5.75 hours. Don't make the mistake of writing 5 hours and 75 minutes. I know it seems like it's something you wouldn't do, but I swear it happens every year, and I hate taking off points for it. Take the 0.75, times it by 60, and you get 5 hours and 45 minutes, okay? So that's where this math is coming from. We're going to have a lot more practice online and in class of this, but this is what we're looking at for the tank duration. When you get to liquid oxygen, it's different math. You're talking about a totally different thing. So liquid oxygen, we talked about how the weight of the liquid is what equals the volume, that you cannot use pressure for liquid oxygen because vapor pressure stays present as long as liquid is present. So big takeaways, 1 liter of liquid oxygen produces 860 liters of gaseous oxygen. So that means a little bit of a liquid, right, makes a ton of the gas. So 1 liter of liquid oxygen produces 860 liters of gaseous oxygen. That's why for bulk systems, it's almost always liquid oxygen, because when you think about the fact that this converts to so much of this, it's an easy way to store a lot of oxygen in a smaller space, okay? So a little liquid goes a long way. 1 liter of liquid oxygen weighs 2.5 pounds. So these are like the 2 big things that you guys are going to need for all of your math. You know that 1 liter of liquid oxygen makes 860 liters of gas, and you also know that 1 liter of liquid oxygen weighs 2.5 pounds. So step 1 is going to be convert your pounds of liquid oxygen to liters of liquid oxygen, okay? So you will be given a weight of liquid oxygen in your practice problem. So you take the weight that they give you and you divide it by 2.5 pounds per liter. And you're just getting that from that previous conversion factor. After you get that new weight, you then multiply that by 860 because you know that that 1 liter equals 860 liters of gas, okay? So after that, the math gets to be the same. You have your liters of gas divided by your flow rate. This is what it looks like, okay? So weight of liquid oxygen times 860 divided by 2.5. You can do it however you want. We'll go through a lot of practice on this. The big caveat for this one is sometimes on the boards, they will give you the liquid oxygen already in liters. And what almost always happens, it's definitely something I have done, is you divide by 2.5 because you read it as pounds. So you have to pay attention to your units. And I'll show you what I mean when we do some practice with this going forward. Okay, so Nancy is going to MRI for a procedure. She is currently using a 2-liter O2 flow via nasal cannula. A portable liquid oxygen tank is available. It is full and holds 1.5 pounds of liquid oxygen. How long will the liquid tank last if running to empty? In minutes and in hours and minutes. So for step one, you're going to figure out how many pounds of liquid oxygen you have. So they said that if it's full, it's 1.5. So you take 1.5 pounds divided by the 2.5 pounds you know that make up a liter. That gives you 0.6 liters of liquid oxygen, right? So now you're going to figure out how many liters of gaseous oxygen you have from this. So you take the 0.6 liters that you have here times 860 liters, which gives you 516 liters of gaseous oxygen, okay? Your next step is going to be to take that 516 that you just solved for and divide it by the 2 liters per minute that your patient is on, okay? So that gives you 258 minutes. You then are going to convert your 258 minutes into hours. So you get 4.3 hours. You take your 0.3 times 60, which equals 18 minutes. So 4 hours and 18 minutes until this is empty. Now, I realize this one is a lot of steps. I also realize thinking about it from a liquid to a gas kind of takes a minute for your brain to wrap around, but we are going to do a lot of practice in class and online. It's not too terrible when you get used to it. So this is an example of what I was talking about where they'll give it to you in liters and not in pounds, and that takes away a step. So how long in hours and minutes will 1 liter of liquid oxygen last if it is being delivered to a patient at 2 liters per minute? So you would just take your 1 liter of liquid oxygen and multiply it by 860 liters. You don't have to worry about pounds because you didn't get it in pounds. You got it in liters already. So that pound conversion is just to take pounds and convert it into liters. Here, they gave it to you in liters. So 1 liter times 860, again, 860 liters of gas. You take the 860 liters, you divide it by the flow rate that is being delivered to your patient to get 430 minutes, right? You're going to then convert that into hours and minutes. So 430 divided by 60 minutes is 7.1 hours. 0.1 times 60 equals 6 minutes. So 7 hours and 6 minutes until empty. On this one, I think it was like 7.16 maybe. I can't remember exactly what it came out to be, but I wanted to point out that when you're doing these tank duration problems, you're always going to want to round down. And that's because it's really important for patient safety. When you think about the fact that you're not going to always end up with whole numbers, if let's say I rounded this up to 7.2 and then did the 0.2 times 60, I would have a longer time than what the tank would actually last. And that's not something you want to tell your patient. So when you're doing these problems, it just makes sense if you're kind of on the cusp, I always round down. So in this situation, I wouldn't even probably say 7 hours and 6 minutes, although you still have to know how to solve for that. I would just say like 7 hours, just to be safe. So that's kind of a quick run through of the math. Again, we will have more online practice and in-class practice on that. That's just an explanation so that you guys can hopefully start kind of tinkering with it and wrap your brain around it before you come in.